Section 4.4. Using a configuration server with Spring Cloud Config Client. The config service application built in the previous section is a server that exposes configuration through a REST API. In general, applications would interact with this API, but you can use Spring Cloud Config Client for Spring applications. This section will teach you how to use Spring Cloud Config Client and integrate catalog service with the config server. You'll see how to make the interaction more robust and how to refresh the client's configuration when new changes are pushed to the config repo. Section 4.4.1. Setting up a configuration client. The first thing you'll need to do to integrate a Spring Boot application with a config server is add a new dependency to Spring Cloud Config Client. Update the build.gradle file for the catalog service project, catalog service, as follows. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 4.14. Adding dependency for Spring Cloud Config Client.
We now need to instruct catalog service to fetch its configuration from the config service. You can do that via the spring.config.import property by passing config server as the property value. You probably don't want the config server running in your local environment when working with client applications like catalog service, and in that case you can make the interaction optional with the optional prefix optional config server. If the config server is not running when you start catalog service, the application will log a warning, but it won't stop working. Be careful not to make this optional in production, or you'll risk using the wrong configuration. Next, catalog service needs to know the URL to contact the config service. You have two options. Either you can add it to the spring.config.import property, optional config server, localhost 8888, or rely on the more specific spring.cloud.config.uri property. We'll use the second option, so we only need to change the URL value when deploying the application in different environments. Since the config server uses the application name to return the correct configuration data, you'll also need to set the spring.application.name property to catalog service. Remember the application parameter? That's where the spring.application.name value is used. Open the application.yml file for your catalog service project and apply the following configuration.
Listing 4.15. Instructing catalog service to get config from config service.
Let's go ahead and verify that it works correctly. The catalog service application contains a polar.greeting property with the value "Welcome to the local book catalog." When using a configuration server, the centralized properties take precedence over the local ones, so the value you defined in the config repo repository will be used instead. First, run config service /gradle wbootrun, then package catalog service as a jar artifact /gradle wbootjar, and run it as follows.
See this code?
Then, in another terminal window, send a GET request to the root endpoint.
See this code?
As expected, the welcome message returned by the application is the one defined in the config repo repository, specifically in the catalog service.yml file. You can also try running the application with the prod profile enabled. Stop catalog service with Ctrl+C and then start the application again with prod as an active profile.
See this code?
The expected result is now the message defined in the catalog service prod.yml file in the config repo repository.
See this code?
Once again, stop the previous application's execution with Ctrl+C. The following section will cover how you can make the interaction between application and config server more fault-tolerant. Section 4.4.2. Making the configuration client resilient. When the integration with the config server is not optional, the application fails to start up if it cannot contact a config server. If the server is up and running, you could still experience issues due to the distributed nature of the interaction. Therefore, it's a good idea to define some timeouts to make the application fail faster. You can use the spring.cloud.config.requestConnect timeout property to control the time limit for establishing a connection with the config server. The spring.cloud.config.requestRead timeout property lets you limit the time spent reading configuration data from the server. Open the application.yml file for your catalog service project and apply the following configuration to make the interaction with config service more resilient. Once again, there's no universal rule for setting up timeouts. Depending on your architecture and infrastructure characteristics, you might need to adjust these values.
Listing 4.16. Making Spring Cloud Config client more resilient.
Even if config service is replicated, there's still a chance it will be temporarily unavailable when a client application like Catalog Service starts up. In that scenario, you can leverage the retry pattern and configure the application to try again to connect with the config server before giving up and failing. The retry implementation for Spring Cloud Config Client is based on Spring Retry, so you'll need to add a new dependency to the build.gradle file for your Catalog Service project. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 4.17. Adding dependency for Spring Retry in Catalog Service.
In Chapter 8, I'll explain the retry pattern in detail. For now, I'll show you how to configure Catalog Service so that it retries connecting to config service a few times before failing. spring.cloud.config.retry.max attempts. Each connection attempt is delayed according to an exponential backoff strategy, computed as the current delay multiplied by the value of the spring.cloud.config.retry.multiplier property. The initial delay is configured by spring.cloud.config.retry.initial-interval, and each delay cannot exceed the value of spring.cloud.config.retry.max-interval. You can add the retry configuration to the application.yml file in the Catalog Service project.
Listing 4.18. Applying retry pattern to Spring Cloud Config Client.
The retry behavior is enabled only when the spring.cloud.config.failFast property is set to true. You probably don't want to retry in your local environment if the config server is down, especially considering we made it an optional backing service. Feel free to test the application's behavior when retrying the connection with the config server down, but remember to set the failFast property back to false if you want to keep it optional in your local environment. In production, you can set it to true using one of the strategies covered in this chapter. When you're done testing the applications, stop both of them with Ctrl-C. You are now ready to use the config service to configure any application you want. However, there's still an aspect I haven't covered yet. How can we change the configuration at runtime? Section 4.4.3. Refreshing configuration at runtime. What happens when new changes are pushed to the Git repository that's backing the config service? For a standard Spring Boot application, you would have to restart it when you change a property, either in a property file or an environment variable. However, Spring Cloud Config gives you the possibility to refresh configuration in client applications at runtime. Whenever a new change is pushed to the configuration repository, you can signal all the applications integrated with the config server, and they will reload the parts affected by the configuration change. Spring Cloud Config offers different options for doing that. In this section, I'll show you a simple refresh option consisting of sending a special post request to a running Catalog Service instance to trigger the reloading of the configuration data that is changed, hot reload. Figure 4.11 shows how it works.
Figure 4.11. After changing the configuration in the Git repository backing the config service, a signal is sent to Catalog Service to refresh the parts of the application using the configuration.
This functionality is one of those administrative processes described by the 15-factor methodology introduced in Chapter 2. In this case, the strategy adopted for managing the process was to embed it in the applications themselves, with the ability to activate it by calling a specific HTTP endpoint. Note: in production, you'll probably want a more automated and efficient way of refreshing configuration than explicitly triggering each application instance. When a remote Git repository backs your config server, you can configure a webhook that notifies the config server automatically whenever new changes are pushed to the repository. In turn, the config server can notify all client applications through a message broker like RabbitMQ using Spring Cloud Bus. Chapter 14 will cover more scenarios for refreshing configuration in production. Enabling configuration refresh. After committing and pushing the new configuration changes to the remote Git repository, you can send a post request to a client application through a specific endpoint that will trigger a refresh scope refreshed event inside the application context. You can rely on the Spring Boot Actuator project to expose the refresh endpoint by adding a new dependency in the build.gradle file for the catalog service project. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 4.19. Adding dependency for Spring Boot Actuator in catalog service.
The Spring Boot Actuator library configures an /actuator/refresh endpoint that triggers a refresh event. By default, the endpoint is not exposed, so you have to enable it explicitly in the application.yml file of your catalog service project, catalog service.
Listing 4.20. Making Spring Boot Actuator expose the refresh endpoint.
Note: I will discuss Spring Boot Actuator extensively in Chapter 13, so don't worry if you don't fully understand the preceding configuration. For now, it's enough to know that Spring Boot Actuator provides many useful endpoints for monitoring and managing applications in production. The refresh event, refresh scope refreshed event, will have no effect if there is no component listening. You can use the refresh scope annotation on any bean you'd like to be reloaded whenever a refresh is triggered. Here's the nice part. Since you defined your custom properties through a configuration properties bean, it is already listening to refresh scope refreshed event by default, so you don't need to make any changes to your code. When a refresh is triggered, the Polar Properties bean will be reloaded with the latest configuration available. Let's see if it works. Changing configuration at runtime. In this final section, I'll show you how to change configuration at runtime. First, make sure you have both the config service and catalog service up and running, /gradle boot run. Then open the config repo repository hosting the configuration data and change the value of the polar.greeting property in the config repo/catalog service.yml file.
Listing 4.21. Updating the welcome message value in the config repo.
Next, commit and push the changes. Config service will now return the new property value. You can check that by running the HTTP 8888 catalog service default command. However, no signal has been sent yet to catalog service. If you try running the HTTP 9001 command, you will still get the old welcome to the catalog from the config server message. Let's trigger a refresh. Go ahead and send a post request to the catalog service application at the /actuator/refresh endpoint.
See this code.
This request will trigger a refresh scope refreshed event. The Polar Properties bean, because it's annotated with configuration properties, will react to the event and read the new configuration data. Let's verify that.
See this code?
Finally, stop the execution of both applications with Ctrl+C. Good job! You have just updated the configuration of an application at runtime without restarting it, without rebuilding the application, and ensuring the traceability of changes. It's perfect for the cloud. In Chapter 14, you'll learn more advanced techniques for managing configuration that you'll need in production, including secrets management, config maps, and secrets.